Hey guys, welcome to my channel. So today's our Leetcode daily challenge problem is minimum ASCII delete sum for two strings. So we are given two strings S1 and S2. We have to return the lowest ASCII sum of the deleted characters to make two strings equal. So we are given this particular example where S1 is SEA and S2 is EAT. Okay. So if I delete this S from the string 1 and T from the string 2, both our S1 and S2 becomes equal, that is EA is equal to EA, right? So if we are deleting S and T, we have to add the sum of the ASCII values of these two characters. So the ASCII of S1 is 115 and S2 is T is 116. So we will return 231, which will be our answer. Similarly, in the second example, from delete and delete words, if I delete LE, this D, E, E, and any of the E from this particular string, it becomes LET. Okay, and the four character that we have deleted, the sum of this ASCII is 403. Okay, so hope you have understood the problem. So what we will do to solve this particular problem? What will be our approach? What we will do is we will simply try to find all the possible combinations, okay, of these two strings, and at the same time we will compare them. As soon as they becomes equal, then we will follow some steps. So majorly we are following the four steps here, so basically that you have to keep in mind. Okay, so see, what we will do is when, so the first condition is whenever the two characters in both the strings are equal, we will skip. Means we will suppose I have I index as a 0. I is pointing to 0th index of S1, j is pointing to 0th index of S2. Okay, so I is S, j is E. Okay, so if both of these are equal, so currently they are not equal, but suppose they are equal, then what we will do is we will simply increment I by 1 and j by 1. Okay, this is the first condition. And what is the second condition? Second condition, if they are not equal, which is in this case, so I is 0, j is 0, so I is pointing to S, j is pointing to E, they are not equal, then we can do two things: either increment I by 1 or increment j by 1. Okay, so these are our second and third condition. So example, here S and E are equal, so we will follow the condition 2, that is we will increment I by 1, so I will point to E and j is still pointing to E. Okay, so we have followed the second condition. Now E and E are equal, yes, so we will follow the condition 1. Condition 1 states if both are equal, increment I and j by 1, so I will point to A, j will point to A. Again A and A are equal, again first condition, I will increment by 1, j will increment by 1, so I is pointing to 3 and j is pointing to 2, which is T, right? But this is over, like the string is over, and we have T character left. So here comes the fourth condition. So the fourth condition state if you have traversed any of the string and which is you have completely traversed any of this string, like we have completed this string, then what you will do is you will traverse all the characters of the string 2, okay, and add their ASCIIs to the sum and return it. Okay, so basically what I will do is I will suppose EATEN, so Eaton was there, and the string here, both the strings are over at EA, right? So I will add this, I will traverse through T, E and N, and I will sum, take the sum of all these three characters values and return it. Okay, this is our fourth condition. If we come to the code, okay, you will get it in a better way. So forget this TP, this for optimization. So see, I have written this recursion. Okay, here I'm passing this s1 and s2 and 0 and 0. Okay, 0 is nothing but I and j index. I is pointing to string 1, j is pointing to string 2. This is our base, that is fourth condition. That is if I is greater than equal to s1 dot length, that is s1 string is totally completed, then I will take one some variable, I will traverse all the other characters remaining in the s2 string. Okay, uh, sum the uh, like store the ASCIIs in the sum variable and return the sum. Same thing for this s2 string. If the s2 string is over, s1 is bigger, then I will traverse to the remaining characters of the s1 string, store the ASCII value sum and return the sum. Okay, so this was our fourth condition, that is weight base condition. This is our first condition, where if both the characters are equal. If both the characters are equal, we don't have to delete it. So we will not be adding any ASCII value. So we will simply calling a recursion, okay, where I am simply incrementing the index of I and j by 1. Okay. And now the second and third conditions, where the characters are not equal in the string. So we can do two things. Okay, we will increment I by 1 or j by 1. Okay, and at the same time, see, if they are not equal, we are deleting this particular character, no? So we have to add the ASCII value of that particular character. So s1 of I have taken the ASCII value, and I am whatever the value is getting written from this in the future, I will add this, and simply then I will return the minimum of skip I or skip j. Okay, because we have to okay, we have to return the lowest ASCII sum. Okay, that's why. Hope you have understood this problem. If I run this, it is running fine. Okay, but this will give TLE for the recursion approach only. We need to optimize this code. Okay, for optimizing, whatever I will do is I will simply use memoization technique. Okay, so what we will do in the memoization, okay, I have already done this. Okay, okay. So what I will do in the memoization, see, I have taken this DP vector. Okay, this is a 2D vector. Okay, first of all, why we are using memoization? See, in the recursion, the possibility is, see, if we are having both the strings, imagine the both the string are too large, like 50-50 characters. There's a possibility that this I and j particular value is already visited. Okay, so in the recursion, we are not following adding any check that if those I and j characters are already visited or not. If they are visited, again we are following the same path. We are getting the same answer. Okay, that's why it is giving TLE. So what we will do is we will create a 2D vector named DP. Initially, I am storing -1 into it. I am passing this DP as a reference. Okay, and what I will do is whenever I am returning any value, before returning, I will store it into this DP of ing. That is, we have visited this particular path. So now, whenever you visit this particular path, you simply return this particular value. You don't have to move forward. Okay, follow the same path again. So wherever, this is a simple trick, when wherever you are returning this particular value, just add TP of ij is equal to this. Okay, so basically before returning we are storing it, and we have to add a check. So here, before solving anything, before calling recursion, I am adding a check that if a TP of ij is -1 or not. If it is -1, that means it is it is not equal to -1. That means it is not visited. It is already visited. Okay, so simply I will return db of ij. Okay, simple. Hope you have got it. If I submit this problem, it is accepted. Okay, so that's all, guys. Hope you have understood this problem. If you have any doubts, you can add it into the comment section. I will definitely reply. You can please make sure to like and subscribe to the video. Thank you. See you in the next video. Till then.